These are notes over 0 and negative exponents. First, I just wanted to kind of show a pattern. So we're going to find 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, and 2 to the negative 4, and try to find a pattern between these. Well, if you remember the exponents, 2 to the 4th means 2 times 2 times 2 times 2. So 2 multiplied together 4 times, and this is actually 16. So we have 16. 2 to the 3rd is 8. 2 to the 4th is 4. 2 to the 1st power is just plain 2. 2 to the power of 0 equals 1. And here is where we get into a little bit more. And you have 2 to the negative 1st power, and this is actually 1/2. 2 to the negative 4th power is 1/4. 2 to the negative 3rd is 1/8. And then lastly, for our example, we have 1/16. And this will gets us two rules. First one, that anything to the 0th power is actually just 1. So anything to the power of 0 is 1. And that can be anything. So if you see it to the power 0, you can just simply say, oh, that's 1, no matter how ugly it looks. And then notice how this works. 2 to the 1st power is 2, but 2 to the negative 1st is just 1/2. We have 4 and 1/4, 8 and 1/8, 16 and 1/16. That takes us to our second rule, that anything that's to the negative power, so a to the negative n, for instance, is 1/a to now a positive n. And that's just saying that if we have 2 to the negative 2, that's the same as saying, so 2 to the negative 2, here's an example, is the same as saying 1/2 to the, now making that a positive exponent, so pretty much we move this down. And then 2 squared, yeah, that's 4, so we have 1/4. And that's a rule that we will be using. So to look at some examples on this, remember, keeping your rules in mind, example number 1 will be 4 to the negative 4. And if you don't want to multiply out 4 times 4 times 4 times 4 times 4 and everything, there's something in your calculator I want to show you. But first, this is a negative exponent, so we have to move it. It's on top. If it's a negative exponent, we have to move it to the bottom. So this will be 1/4 to the power of 4. So we have 1 over that. And if you don't want to, again, multiply it all out, there's this nice button on your calculator. So we have 4 that we'll type. And then notice there's this caret button right here that we will push. 4 to the power of 4. That gives you 256. If you can see it, there we go. 256. So now we know that this is 1/256. So that caret button will come in handy for those exponents that are big enough that you don't have memorized. Okay, here's a second example. We have -6 squared. Let's think about what this is. Actually, there's no negative exponent, so we don't have to move them up or down. We know what 6 squared is. That's 6 times 6, which is 36. This negative out front has nothing to do with the exponent, so we just keep it -36. And let's look at this, and we're kind of contrasting numbers 2 and 3 here. If this is in parentheses and we have -6, close parentheses, squared, notice for number 2, the negative was not in parentheses. The squared had nothing to do with the negative. So it's not like we did a negative times a negative to be a positive, because then this negative was not being squared. But when it's inside the parentheses, this is -6 times -6 that we're talking about. So -6 times -6, when it's inside the parentheses, gives us a positive 36. Okay, number 4. We have negative 10 to the negative exponent of 3. And we need to solve this. So notice this negative that's on the outside, that'll just stay on top, but this whole part is going to be moved to the bottom because we cannot have negative exponents. You always have to make them positive before you can go further. So we're going to make it positive by moving it to the bottom. So we have 10 cubed. And then so we have negative 1 on top, and 10 cubed is going to be 1,000. So we have negative 1 over 1,000 as example number 4. Okay, then with number 5, we have negative, and then in parentheses 1.2563 to the power of 0. Oh, remember, anything to the 0th power is just 1. But that negative is not part of it. So we have negative still, and then what's in parentheses becomes 1, and this leaves us with our final answer of negative 1. Those are some of the examples with numbers, but you can also do this with the variables. So let's look at number 6. And remember, your whole goal is you cannot have negative exponents in your final answer. You always have to make them positive. So if we have y to the negative 3, x to the negative 4, if we're looking at this, oh, this is a negative exponent, it's got to move down to the bottom. This is a negative exponent, we have to move it down to the bottom, and this will be 1 over y cubed x to the 4th. Now we don't have any negative exponents, and we are good. Looking at number 7, we have n to the negative 1st power, n to the 0, and over w squared. So when we do this, you look at every single variable separately. So let's just look at the n for a second. Oh, it's a negative exponent, so this is going to be moving down to the denominator. Oh, but n to the 0, that's just going to become 1. And w squared, well, that's a positive exponent, so it stays right where it is. So if we look, we're going to have 1 in the numerator, but n moves down, and you don't have to put to the 1st power, it's implied, and then w squared stayed right where it was. So we have 1 over n w squared for number 7. We continue looking at examples. Here's number 8. We have 3ab squared. Oh, to the negative 2, sorry. So 3ab to the negative 2. Your whole goal in here is to get rid of negative exponents. So that's what you're looking for. 3 does not have a negative exponent. A does not have a negative exponent, so both of those stay where they are, but b to the negative 2nd does, so we need to move that down. So this is going to become 3 and a stayed on top, but b squared comes to the bottom. When you move it down, you now make it a positive exponent. They're all positive exponents, and we're done with that answer. I have a couple more examples like this. So number 9, we have 12 to the negative 2nd, a squared, b to the negative 3rd, and that's all over c to the 6th, and d to the negative 8th. So when we're looking at this, you look at each number and letter separately for their exponent. It's all separate. None of it's together. So you have 12 to the negative 2nd. Oh, that's a negative exponent. That's going to be moving down. A squared. Oh, positive exponent stays right where it is. B to the negative 3rd. Oh, negative exponent. We have to move it. C to the power of 6. Positive exponent stays right where it is. And then here's the first time we've seen d to a negative 8. This is the first time we've seen a negative exponent in the denominator. And we can't have negative exponents. So what we're going to do is, if this is on the bottom, to make it a positive exponent, we move it to the top. So when you're looking at this, we have now a squared on top, that stayed on top. Both of those move down, but notice d to the 8th will move up. But we had 12 squared, that's still on the bottom, okay, or move to the bottom, b cubed moved to the bottom, and c to the 6th stayed right where it was. But the thing is, this isn't quite done because I don't want you to leave it a number to an exponent. I want you to actually put what 12 squared is. So we have a squared d to the 8th over 12 times 12 is 144. B cubed c to the 6th. And that is your final answer. So it's supposed to be 144. B cubed c to the 6th. And I only have one more example like this, and then I'll show you how to evaluate with these. So here is number 10. We have negative 3 x to the 5th over y to the negative 4th. Okay, negative 3 has a negative in front of it, but it's not in the exponent, so it stays right where it is. X to the 5th, okay, that's a positive exponent, so x to the 5th will stay on the top. But then we get down to y to the negative 4th. All negative exponent, so if it's on the bottom, we need to move it to the top in order to make it a positive exponent. So this is going to be negative 3 x to the 5th, y to the 4th. And that's how you work out this problem. So the main idea is you can never have a negative exponent. If you do, if the negative exponent's on the top, you'll move it to the bottom. If it's on the bottom, you move it to the top and make it positive. So make sure in your final answers you should never have negative exponents.